This is my third video of the section 11.5, Planes in Space. First, let me explain the normal vector of a plane. Yes. Suppose this is a plane ABCD, ABCD. Then what is the normal vector of this plane? Yes, it is a vector perpendicular to this plane, right? So I use n. So that is the normal vector of this plane. So the plane containing the point x, y, x1, y1, z1. So I use this point as x1, y1 and z1. And having normal vector n. Yes, we have normal vector, it is n. I use that A, B, C. We can define a special plane. Let's see. We can first find a point on this plane from anywhere. So it is a general one. So this is a general point. We don't know this exact one. So I use that x, y, z. So x, y, z. Let me use another color. Yes. So I use this. I pick this point. Okay. It is x, y, z point. It can be anywhere on this plane. Anywhere. Right. So now I use this is P and this is Q point. Then we can find the vector PQ. Okay, what is the vector PQ? Vector PQ equal, you know, that is x minus x1, y minus y1 and z minus z1. That is the vector PQ. Now if n, this one is the normal vector to this plane and n must be perpendicular to PQ. You understand that, right? N is the normal vector to the plane, therefore n must be perpendicular to the PQ vector. Since PQ and n are perpendicular, we can write the dot product n dot PQ equal absolute n and PQ vector, the magnitude of PQ vector and magnitude of n vector time cosine 5 over 2, cosine 90, right? So this is 0. Therefore, we can have n vector time PQ vector equal 0. Now, what is the n? N is A, B, C. So I use A, B, C and PQ vector x minus x1, y minus y1 and z minus z1. So this equals 0. So now we can simplify this. We can have A time x minus x1 plus B time y minus y1 plus C time z minus z1 equals 0. So this is the standard form of the equation of a plane. Of the equation of a plane. Again, as a summary, you see we know this P point, x1, y1, z1. We know that point and we know the normal vector to the plane. Then we can find the equation of the plane using these steps. Now, you see we can simplify this A as ax plus by plus cz minus ax1 minus by1 minus cz1, this equals 0. So by regrouping terms, we can obtain the equation like this: ax plus by plus cz plus d equals 0. You know d is negative ax1 plus by1 plus cz1. So this is called the general form. The general form of the equation of the plane. So that is the general form. This is the standard form. Right. Now, what do you think if planes are parallel? Yes. If planes are parallel, what do you think about the normal vectors of them? Yes, they have the same normal vector. Right. So let me explain this using an example. I discussed the exercise. This example I discussed. This is the problem number 42 of the exercise, page number 795. So find an equation of the plane that passes through the point 0, 0, 0. You see the plane, it has a point 0, 0, 0 and is perpendicular to n. So this perpendicular to this, I say n, it is negative 3, 0, 2, perpendicular to this. Then how do we find the equation of this plane? Yes, you know, you can use directly the equation. You know a x minus x1 plus b y minus y1 plus c z minus z1 equals 0. So we know a is negative 3 x minus 0, that is x1. You know, comparing this is x1 and y1 and z1. Compare with the theory I explained above. So this one is what? A and B and C. So plug those. So then B is 0. Therefore it becomes 0. Y minus 0 and plus C is 2. Z minus 0 equals 0. So answer is negative 3x plus 2z equals 0. Next example, the problem number 46. So there are 3 points on this plane. It is P, that is 3, negative 1, 2, and Q, 2, 1, 5, and R, 1, negative 2, negative 2. Yes, we know 3 points on the plane. Then how do we find the equation of this plane? Yes, first we should know the theory. We need to find the perpendicular vector to the a normal vector to this plane and a point. Yes, we know already 3 points. So I use this one as our point, right? Then I say I can write down P 3, negative 1, 2. So this is the x1 and this is y1 and this is z1. Yes, we know that. Next, we need to find the normal vector. How do we find the normal vector? Now you should know the cross product. Yeah, if we can find 2 vectors on the plane and having cross product, we can get the normal vector, right? So I use PQ and PR vectors. Okay, you know how to find the PQ vector and PR vector. So I use the cross product. So I, J, K. So I should be here 2 minus 3 negative 1 and 2 and 3. 5 minus 2 is 3. PR is 1 negative 2 and negative 1 and negative 4. So get the cross product, that is negative 5, negative 10, 5. So you can get negative 5 out. So then 1, 2, negative 1. Yes, now you know what is the PQ cross PR? That is a normal vector to this plane, right? Because PQ and PR on the plane, and you know cross product must be the vector that perpendicular to both PQ and PR. Therefore, this PQ cross PR must be the perpendicular vector or normal vector to this plane. Right, now we know that, and therefore this is we can use A, B, C general form. So I use this is A and this is B and this is C. So we can write the equation A time x minus x1 plus B time y minus y1 plus z time z minus z1 equals 0. So A is 1. So therefore x minus 3 plus B is 2 and y minus 1, right, negative 1 plus z negative 1 and z minus z1, c1 is 2 equal 0. So multiply this and simplify this. So x plus 2y minus z, then this become plus 1 equal 0. My next question is, suppose equation of a plane is given by this 2x plus 3y minus 4z plus 10 equals 0. So this is a equation of a plane. Then how do we find the normal vector to this plane? Yes, so now you should know the equation of the plane. Let me explain. A, x minus x1 plus b, y minus y1 plus c, z minus z1 equal 0. After we simplify this, we can get the general form by plus cz minus a x1 plus b y1 plus cz1 equals 0. So you see what are these ABC? ABC are the coefficient of normal vector xyz, right? So therefore, when you know the equation of a plane like this, then we can say n is the coefficient of xyz and 2, 3 and negative 4. So this is the normal vector to this plane, right? So you should know how to get those information. My next example, there is a line. So this I say L x minus 3 over 4 equal y plus 2 over 2 equal z plus 3 over 5. So this is a line. Okay, this now problem explain this way. Suppose a plane containing the line, this line, and has a point P 2, 1, negative 3. Then how do we find the equation of the plane. Yes, let me get these informations. So this is a plane and we have line this, so that is L, and a point on the plane, so I use this, that is P 2 1 negative 3. Then how do we find the equation of this plane? To find the equation of this plane, we need a point on the plane. Yes, we already know that, but we need a point on the plane. So I use that 2 1 negative 3, and we need a perpendicular or normal vector to this plane, right? So what is the normal vector? Oh, we don't know that, right? Now think about the line. What are information we can get from the line? Yes, if you go back to the theory, we know this 4 2 5. What are those? Those are the, vector v, direction vector of the line. V is 4 2 5. Could you remember? That is the direction vector. Okay, that means it's parallel to the line, this line, right? Then what are these? 3 negative 2 and negative 3, and using this, this one, and here this, and here this one, but you see this is positive, therefore we can get a point on the line. I could say this here, it is, I use Q, so we know a point on the line, it is 3 negative 2 3, right? Now we know a point on the line, that means this point is on the plane, so I use, that is QP, Q point, and we know the parallel vector to the L, right? So direction vector, right? Therefore now our target is to find the n. N is the normal vector. Now how do we find the n? Yes, we can get the QP vector. First, let me get the QP vector. QP vector is this. So QP vector is what? That is 2 minus 3 negative 1, and 1 minus 2, yes, it is 3, and other one is 0. Right, that is the QP vector. And we also know a vector parallel to L, the line. That is what? That is the V. So V is 4 2 5. It should be something like this. You see that is V. Yes, right? Then how about, can we get the cross product of QP and V? Yes, once we have a cross product, so what can we get? We can get the normal vector of this plane, that is the cross product. Therefore, n equal, I say QP cross V. So this is I, J, K, negative 1, 3, 0, 4, 2, 5. So answer is 15, 5, 10. And we can get 5 out. So 3, 1, 2. Alright, now we know a point. Yes, we know this point. And also now we know n. What is n? I would like to say 3, 1, 2, this. Now can we write the equation? Yes. We know equation is a time x minus x1 plus b time y minus y1 plus c time z minus z1 equals 0. So a is here, we know that is a should be the perpendicular vector. So that should be 3 times x minus x1 plus b is 1 times y. Actually, what is the x1? I'm sorry. x1 is 2 and y times y1 is 1 plus c mean 2 times z plus 3 equals 0. So you can simplify this, get the general form, and this is 2z minus 1 equals 0. So this is the equation of this plane. Next one, how do we find the angle between two planes? Angle between two planes. Yes, so let me explain this. So suppose this is a first plane, right? So we have angle like this, the perpendicular or normal vector n1, right? So then we have another plane in this way, right? This one, another plane. So this perpendicular vector, I use this like that, it is n2. So this is actually perpendicular to this plane, you know that. Then how do we find the angle between these two? Angle is this, that is theta. Then you know the angle, the same angle we have between the perpendicular normal vectors, right? So this is a theta. So if we can find the angle between normal vectors, that is the same angle between two planes, right? Therefore, you know we can write cosine theta equal magnitude of n1, absolute value of n1 dot n2, absolute value, divided by n1 vector and n2 vector magnitudes. So this is the cosine theta. So we can have theta equal cosine inverse n1 dot n2 divided by n1 times n2 this. So two planes are perpendicular when you already know n1 dot n2 equals 0. Two planes are parallel when n1 is a scalar multiple of n2. Now example, find the angle between the two planes. I give you first one, x minus 2y plus z equals 0, and the next one, 2x plus 3y minus 2z equals 0. How do we find the angle between these two planes? Okay, so yes, you know from this one we can have n1, the normal vector is 1, negative 1, 2, 1. And from this equation we can have a normal vector 2, 3, negative 2. Then we can find the cosine theta n1 dot n2 absolute value and magnitude of n1 and magnitude of n2. So you can find the dot product. So that is negative 6 absolute value and 6 and 17. So this is 6 over 1 over 2. Therefore theta equal cosine inverse 6 over 1 over 2 square root. This. So you can find this dot product, right? You know n1 dot n2 equal 1 negative 2 1 dot 2 3 negative 2. So this you multiply 2 plus negative 6 minus plus negative 2 this. So that's way you can get the negative 6. Okay, so you know how to find the magnitude of that. Then find the parametric equation of their line of intersection. Right, how do we find the parametric equation of the the line of their intersection, right? How do we find it? Suppose we have this plane here and another plane like this. Okay, so intersection line is this. You see that this one. How do we find this line? You see on this line the points of the both planes must be the same, right? Therefore, let me consider these two equations, 2y plus z equals 0. I say that is first one, and 2x plus 3y minus 2z equals 0. That is the second one. So using these two equations, we need to find the x, y, z. Yes, you know we cannot find x, y, z exact value because there are three variables but two equations. Actually, this is not just one point. There are many points. You see there, right? Infinitely many points on this line, right? So therefore, we need to find the line. Okay. So therefore, what I do, I use 1 and 2, and I get rid of one variable. So it is easy to get rid of, I think, from x variable. What I do, I multiply first equation by 2. Then you will get 2x minus 4y plus 2z equals 0. So this is third one. So then what I do, then I use this. So third one, then 3 minus 2 equations, right? Then 2x minus 2x 0 minus 4y, then minus 3y, it becomes negative 7y, and plus 4z equals 0. From this we can have y equal 4z over 7. Then we know y, therefore we can find the we know y in by z. So what I do, I use this, I use z equal t, then z equal t, then y equal 4t over 7. Now I plug these two z and y values to the first one. So first equation, you will get x minus 2y 4t over 7 plus z t equals 0. From this you can have x equal 1 over 7. Now we can 1 over 7 t, right? Therefore we can write the equation of the line. What is that? X equal 1/7 t and y equal 4t over 7 and z equal t. That is the equation of the this line, the line of intersection. Next, the line of intersection of the two planes is parallel to the cross product of their normal vector. That means suppose you have here one plane and next one is this, right? So this is n1 normal vector and n2 this. So n1 cross n2 should be parallel to this. So n1 cross n2 is parallel to this way.